A person intends to go to his home at point B from his factory A. Now we need to find the minimum possible time in which he can go from point A to point B. There are two things. One is that he can walk through the plain road, which is AX and XB, with a speed of 2v, or there is another region, this region, which is a paddy field actually. So whenever he tries to enter this region, his velocity reduces by 50%, the speed reduces by 50% and becomes v. So we are also, let's say, given that the length AX road is of L length and XB road is of L by 2 length. So what should be the minimum time of going from point A to B? A very generalist approach to this problem would be considering that this person starts at A and moves some distance on the line AX, and then at some point, let's say at Y, he decides to move into the paddy fields. So let's say he directly starts into the paddy fields, and from here he directly heads towards point B. So this is a very generic kind of a situation, and then I need to find probably this angle. Let's say if it's alpha, I need to find what would this alpha be, so as to minimize the whole time. So what generally people would think of in this case is to find out an expression is in time and trying to differentiate it and equating to 0, or taking some other geometrical methods of solving this question. But if we utilize a very important property here, and that property is of light, then we can easily solve this problem within fraction of seconds. What's that property of light which can come handy here? The property of light is that whenever it gets refracted across different mediums, and whenever it intends to reach a particular point, it always chooses the path which takes the minimum possible time to reach that final point. I reiterate, whenever a light suffers refraction and it needs to, let's say, reach another particular point, it always will take that path only which takes minimum possible time. So if we consider a applying similar concept in this problem, what we can think of is whenever he is moving on the road, his speed is higher. So if you consider this to be a rarer medium, and this medium where he's getting some obstruction such that his speed is reduced to be a denser medium. So I'm directly, if I draw normal at this point from where he changes the direction, and let's say this angle is theta, okay. So basically the ratio, if I apply the law of refraction here, I will automatically take into consideration the minimum possible time. So the ratio of the velocities or the speeds in the two medias, what's that? 2v by v must be equal to the ratio of the sine of these two angles, and this angle is normal, so this is 90 degree. So a sine of 90 degree divided by sine of theta. So my sine theta from here is half, so my theta is 30 degrees. So now I know my theta is 30 degree, and once I know my theta is 30 degrees, I have actually solved the problem. If this is 30 degree, this is 60 degree. So what is this length? This is L by 2. So this is L by 2 cot 60 degree. Okay. This entire length was L. So what is this length? L minus L by 2 cot 60 degree. So what's my minimum time here? I need to find, I know that it moves with different speeds in different medias. So this part of the distance, L minus L by 2 cot 60, is traveled at a speed of 2v, and this distance, what is this distance? This is L by 2, this is 60 degree. So what will be this distance? This will be nothing but L by 2 cosec 60, right? L by 2 cosec 60, and this will be divided by velocity v, and this is our t minimum. This is the minimum time that a person will take to reach point B from point A, given that he suffers a reduction in the speed when he enters from one medium to another medium.